Look at this photograph. Not a painting, not an illustration, a real photograph from the 1800s. It shows a tree stump so large that an entire dance floor was built on top of it. People are standing there, dancing, laughing, drinking. The stump itself is wider than most houses. Now look closer. The surface is perfectly flat. Not rough, not jagged, not splintered. Clean, precise. Almost as if it had been cut by a machine. Now shift your attention somewhere else entirely. A canyon wall in the American Southwest. Not the famous sections, the ones most people walk past without noticing. Zoom in. You'll see something strange. Parallel lines, perfectly horizontal. Evenly spaced across hundreds of feet of solid rock. Lines that never drift, never break. Lines that should not exist. Because erosion doesn't work like that. Water doesn't carve straight lines. Wind doesn't either. So the question becomes unavoidable. What if these two things, the trees and the canyons, are connected? In the 1800s, logging companies across Northern California, Oregon, and parts of Nevada documented trees of an almost unimaginable scale. Some of the stumps still exist today, over 30 feet in diameter. The Centennial Stump in Kings Canyon is one of them. The Mark Twain tree stump, now preserved in the American Museum of Natural History, is another. These were real trees. No one disputes that. You can still go and see the remains. But the real question isn't whether they existed. It's how they were cut down. Because when you look closely at the surface of these stumps, something doesn't match the official explanation. The cuts are not rough. They don't show the uneven patterns you would expect from axes or hand-operated saws. Instead, they appear smooth, uniform, almost polished, like something far more advanced than 19th century tools was used. And once you see that, you can't unsee it. The official explanation says these massive trees were cut down using axes and cross-cut saws. For smaller trees, that makes sense. But for trunks measuring over 30 feet in diameter, the math doesn't work. A standard crosscut saw in the 1800s was, at most, around 10 to 12 feet long. That means it could only reach a limited distance into the trunk. It cannot physically cut through the center of a tree that large. The geometry is impossible. You would need a tool that could extend across the entire diameter or rotate around it. Historians suggest teams of loggers worked in stages, cutting from multiple sides using platforms, but there is no detailed documentation showing this method being used at that scale. No step-by-step records, no verified demonstrations, just the stumps, cleanly cut, perfectly flat, and an explanation that avoids the most important question: what actually made those cuts? In 2019, a researcher began documenting something unusual across canyon systems in the American West. What he found was difficult to ignore. On vertical rock faces, far above any waterline, there were marks. Not random marks, not cracks, not fractures. These were parallel lines, perfectly horizontal, evenly spaced, stretching across hundreds of feet of stone. They didn't follow the natural structure of the rock. They cut across it. That detail matters, because natural processes like erosion or pressure fractures follow the internal grain of the material. These lines do not. They look imposed, as if something moved across the surface deliberately, leaving behind a consistent pattern. And it gets stranger. The marks are often most visible in the hardest layers of rock, not the softest, which is the exact opposite of what erosion would produce. Water wears down weak material first. It does not carve clean, consistent lines into solid stone. So if this isn't erosion, what is it? Now take this idea beyond North America. Look at Petra, in modern-day Jordan, an entire city carved directly into sandstone cliffs. The official explanation is that it was built by the Nabateans using hand tools, chisels, and hammers over hundreds of years. But when you examine the site closely, problems start to appear. The walls are smooth, The edges are precise. The angles are consistent across massive surfaces. And perhaps most importantly, there is almost no debris. If thousands of rooms and corridors were carved by hand, where is the waste material? Where are the piles of stone that should have been removed? They are not there. Now look at Baalbek in Lebanon. In the quarry nearby lies a stone block known as the Hajar al-Hibla. It weighs over 1,600 tons. It has been partially cut from the bedrock with edges so clean they look machined. Modern engineering struggles to move stones a fraction of that size. And yet, whoever was working here had the capability to cut it precisely, and then simply stopped, left it in place, abandoned mid-process. And this same pattern appears again and again. What makes this harder to ignore is not just a single site. It's the pattern. Across different continents, North America, the Middle East, parts of Europe, and Central Asia, you find the same characteristics. Massive cutting operations, precise surfaces, minimal debris, and, perhaps most telling of all, work that appears to have been abandoned, not finished, not sealed, just stopped. At Petra, at Baalbek, in canyon systems across the American Southwest, in quarry sites in Egypt and Lebanon, sections where the work ends abruptly, as if whatever process was underway was interrupted. The tools disappeared, the operators vanished, and the site was left exactly as it was. That consistency matters, because independent anomalies can be dismissed, but patterns, especially global ones, are much harder to explain away. Now we arrive at the point where most people stop listening, because this is where the theory becomes extreme. What if certain mountains and canyon systems are not purely geological formations, but the remnants of something biological? Specifically, the stumps and root systems of trees far larger than anything we have reference for today. We already know giant trees existed. The redwoods and sequoias we see now are survivors, but the stumps from the 1800s suggest something much bigger once stood. Some researchers have taken the diameter of those stumps and scaled them using the proportions of modern trees. The result is difficult to process. Estimated heights reaching 1 to 2 kilometers. If that sounds impossible, consider what that implies. A tree that size would require a root system just as massive, and when such a system decays or is removed, it leaves behind voids. In geology, this process is known as subsurface collapse. At that scale, those voids would form long, narrow corridors, branching paths, twisting chambers, structures that look exactly like slot canyons, not carved, but left behind. To be clear, this theory is speculative. There is no confirmed physical specimen of a kilometer-scale tree, no preserved root system, no documented machinery capable of operating at that scale. And that matters, because without direct evidence, any conclusion remains a hypothesis. But at the same time, the anomalies themselves are real. The tool-like marks on canyon walls can be observed, measured, and photographed. The massive tree stumps exist. The missing debris at sites like Petra and Baalbek is a documented absence. The pattern of abandoned, large-scale work is visible across multiple locations. Individually, each of these can be explained within existing scientific frameworks. But together, they begin to resist simple explanation. That's where the tension lies, not in proving the theory outright, but in recognizing that the current explanations do not fully resolve what we are seeing, and until they do, the question remains open. Stand at the edge of a canyon, look at the walls, find those lines, perfectly straight, perfectly consistent, then ask yourself a simple question. Do they really look natural, or do they look made? Because the marks are still there. They haven't disappeared. They haven't been explained in a way that fully satisfies the evidence. They remain, waiting. The question is no longer whether they exist, it's what made them, and why that answer has never been seriously investigated. If something this large, this visible, and this measurable can be dismissed so easily, what else are we overlooking? What else has been explained just enough to stop us from asking better questions? If this made you look at something familiar in a new way, subscribe, because this is only the beginning.